All right, let's talk about a huge breakthrough in how AI models are actually built. A company called DeepSeek just dropped something that looks quiet on the surface, but it could be a massive change to the very foundation of pretty much every large language model out there. We're talking about solving one of AI's biggest hidden bottlenecks. So yeah, let's dive in.
So to really get why this is such a big deal, you kind of have to look under the hood of modern AI. And here's the crazy thing. For years, the very trick that allowed models to get bigger and smarter, it also created this hidden problem, a massive traffic jam right in the heart of how these things learn.
So what is this traffic jam? Well, it all goes back to a concept that's been in AI's DNA for ages, way back to the resonant days. It's the secret sauce that lets models become incredibly deep without, completely losing their minds in the process.
Okay, so this thing right here, the residual connection, this is the absolute backbone of modern AI. Just think of it like an express lane on a highway. It lets information from way back at the beginning of the network just zip right past all the middle layers. This is super important because it keeps the signal strong from start to finish. It's literally the reason we can have models with hundreds and hundreds of layers that don't just collapse during training.
But, okay, here's the catch. An express lane is great, right? But it's still just one lane. And as these models have gotten absolutely massive, we're trying to shove an insane amount of information through this one single pathway. It's become a serious bottleneck. All that complex data has to get squished down into this one channel, and that's just fundamentally holding back how much the model can learn and grow.
So, the next step seems pretty obvious, right? I mean, if one lane is a bottleneck, why not just build more lanes? And that's exactly what a bunch of researchers tried to do.
So they came up with this concept called hyper-connections, or HC for short. And instead of one stream of information, HC basically creates a whole bunch of parallel streams. Suddenly that information highway went from a single lane to a multi-lane superhighway. And in theory, this should have just blown the doors off the model's capacity.
Yeah, in theory. But in reality, it was total chaos. Imagine a superhighway with tons of lanes, but no lane markings, no traffic lights, no rules whatsoever. That's what happened here. The signals flying through these parallel lanes just started mixing together in this totally uncontrolled way. And that just completely shattered the stability that the original single express lane gave them.
And this is the crucial point, right? This chaos basically made hyperconnections a dead end for building really big, powerful models. The training would just go haywire. Performance would spike and then crash. The information signals would either amplify into a massive explosion or just vanish into thin air. It just wasn't practical, not for the kind of huge foundation models we need today.
So this idea of a wider information highway, it was so promising, but it was just too wild and chaotic to actually use. And this is where DeepSeek comes into the picture, with a really brilliant and kind of elegant solution to tame all that chaos.
Then, on January 1st, 2026, DeepSeek drops this paper that proposes a way to bring order to the chaos. They call it Manifold-Constrained Hyper-Connections, or MHC. And this was their answer to that unstable multi-lane mess.
And this is just a brilliant way to think about it using our highway analogy. DeepSeek didn't tear down the multi-lane superhighway. Nope. Instead, they just installed some really smart traffic controllers. They kept the wider pathways, but they introduced a set of rules, this manifold constraint, that controls exactly how information can mix and flow between all those lanes.
Now, what's really cool is how they did it. These traffic rules are basically just a super clever mathematical trick. Now, without getting totally lost in the weeds here, it essentially forces the whole system to act like a conservation mechanism. It makes sure that the total amount of signal flowing through the highway always stays constant, which is what prevents it from ever exploding into noise or just disappearing completely.
Okay, so that's the theory, and it sounds great, but does it actually work in the real world? Let's check out the proof. Let's see how this brand new architecture actually performs when they put it to the test.
Okay, first off, let's talk about efficiency. All of these amazing benefits, a wider information highway with smart traffic control, they come at a shockingly low cost. Thanks to some serious optimization work, DeepSeek says that adding MHC only increases training time by about 6.7%. I mean, that is a tiny price to pay for such a fundamental upgrade to the architecture.
And here is the payoff. What you're looking at is performance on a really tough reasoning benchmark. That first bar, the baseline, that's our old single-lane highway. The middle bar, HLC, that's the wider, chaotic highway. It's a bit better, but it's unstable. And then you've got the MHC model, which just blows them both out of the water. It doesn't just make the training stable, it unlocks a whole new level of performance. And this isn't just a one-time thing either. When you look at a whole bunch of different tests, you see the exact same pattern over and over. It doesn't matter if it's complex reasoning, tricky math problems, or just general language understanding, the MHC architecture gives you big, comprehensive improvements. It's just smarter, all around.
So, okay, a new, more efficient architecture leads to better scores on benchmarks. That's great. But the implications here are so much bigger than that. Let's zoom out for a second and really understand why this matters to pretty much everyone who's following the AI space.
You know, for years, the main way to make AI better has just been brute force. Throw more data at it, use more GPUs, build bigger and bigger models. But what MHSC does is it introduces a totally new way to scale up. It's kind of like discovering you can make a car engine way more powerful, not just by pumping in more fuel, but by fundamentally redesigning the cylinders. This is a new architectural tool. It's like a brand new scaling knob that developers can now turn.
And, you know, there's a pretty fascinating human side to this whole story. The CEO of DeepSeek, a guy named Liang Wenfeng, he wasn't just, managing the research. He was actually listed as a co-author on the paper, and he's the one who personally uploaded it. Now, in the world of AI research, that's a massive signal. It tells you this isn't just some academic thought experiment. Analysts have pointed out that this kind of direct CEO involvement often happens right before a company is about to drop a major new flagship model.
And that brings us to the final and most important question. It looks like DeepSeek might have just paved a brand new, much wider, and way more stable highway for AI. And if this really is a new foundation, well, that changes the entire roadmap for everyone. So the only question now is, how much farther and how much faster can we travel down this new road? We might be about to find out very, very soon.